Hello everyone, welcome to MESS e-learning channel. In this lecture, we are going to solve another problem on the same concurrent force system. But in this problem what we have to do is, we have to find out this force in some string. So let us look into the question first. So this is the question here. So as you can read the question, it says, this is a car which is pulled by two ropes, one rope being pulled by a force of 2.6 kilonewton and other force in the other string. We have to find the tension in this string. But the important sentence here is that the resultant of the car is directed along x-axis. So now let us start resolving the forces here. So these are the two strings pulling the car in a particular direction. So if we resolve the forces, as they are the outward forces, we'll resolve it in the outward direction. So this is adjacent to the angle, so this would be 2.6 cos 32 degrees, and this would be 2.6 sine 32 degrees. Similarly here, this component will be adjacent to the angle, so this would be q cos 28 and this is q sine 28. So now, as we have resolved the forces, let us move on to the solving part. So in the question it was given that the resultant is directed along x-axis. That means the resultant forces are along the x-axis. So yeah, our r will be equal to f of x. And if r is equal to f of x, my f of y would become 0. So these are the two equations that we have to solve now. So we have one unknown as q, other unknown as r, and then we have two equations. So we can easily find out. So the first equation, let us see. So let us solve for f of y equals to 0 first. That is, all the forces in y direction would be equal to 0. So the y force is here, so it would be going upward, so it would be positive. 2.6 sine 32 positive minus, as this force is going down, so it would be minus q sine 28 degrees equals to 0. So if we solve this, it would be q equals 2.934 kilonewtons. And our next equation is r is equal to f of x. So our r is equal to f of x. R is equal to all the forces in x direction. So it is 2.6 cos 32 degrees. Also this force is in the positive direction, so plus q cos 28 degree. So if we calculate, now we have to substitute the value of q here. So it would be 2.6 cos 32 plus q is 2.934 cos 28. So if we solve this, we get our r to be 4.795 kilonewton. In the forward direction, as it is positive. Okay, likewise, if we get a question wherein it is given that the resultant force is along vertical direction or the resultant force is directed along y-axis, then it would be summation of f of y equals to r, because it was in vertical direction or in y direction. And then if it is f of y equals to r, our f of x would become 0. In this lecture, we saw a system wherein we can find a concurrent force system where we are not replacing the system, but we are finding an unknown force using the information given. Hope you understood. If you have any queries, please drop in your comments in the comment section below.